Good morning, class. This is Mr. DeMarco here with another video. What I decided to do, I had a couple emails saying that they're having problems answering the solution reaction questions. So I'm going to walk you through two other examples today using our solution reaction double replacement and determine if something is precipitating or not. Just like last time, you need your table E, your table F, and your periodic table. So please make sure you have those charts out, ready to use as we're going through. You'll see them being used in the video as well. Also, don't forget, you could always pause this along the way to make sure you understand exactly what's happening step by step. Let's take a look at the first example. Here I have CaCrO4 and AlF3. I have these two things in solution. I know they're in solution because it says aqueous AQ. I know this is a double replacement reaction. How do I know? There are four items. Calcium is 1, chromate is 2, aluminum is 3, and fluorine is 4. That's characteristic of a double replacement reaction. So I know that the calcium is going to leave chromate and grab the fluorine. And I draw that in so I know I'm not going to make a mistake. At the same time, the Al is going to leave F and join with the CrO4. So that's my setup. So what I need to do is predict the products on this side and determine if there's going to be a precipitate. Now, how do I do that? Knowing what the matches are going to be, I have to look up Ca, F, Al, and CrO4's oxidation states. I do that using my periodic table and table E. Ca, F, and Al, I'm going to find on my periodic table. They're singular elements. So when I go to my chart, I should see +2, -1, and +3. Calcium is +2, Al is +3, and F is -1. Exactly what we had on our slide. CrO4 is a polyatomic ion, so it's not going to be on the periodic table. It's going to be on table E. So if I take a look at table E, CrO4 has a -2 charge. So that's where the charges are coming from on my starting points. Now I have to carry out my formula writing swap and drop piece. The numbers are going to switch spots and drop into place. So the Ca's 2 goes to the F and the 1 goes to the Ca. And remember that we do not write the 1s in chemistry for formula writing. It's implied that it's already there. The aluminum chromate does the same thing. The 3 is going to swap over to the chromate and drop into place. Here, because there's two numbers side by side, I have to designate parentheses to keep the polyatomic ion together. It's always safe to put polyatomics in parentheses, just in case if you forget, you don't get it wrong. So the Al3 comes over to the chromate and drops into place, and the 2 from the chromate comes over to the Al and drops into place. So these are my two products that are going to show up on this side of the reaction. I need to know, though, are they soluble or not? And then I can put the correct states of matter. CaF2, Al2CrO4, I am now going to look up using my table F. On table F, it says Ca, not here, it's not here. So that means the F is going to be somewhere. And notice that the F is a halide because it's in group 17, just like Cl, Br, and I. So knowing that it is a halide, it's going to be soluble except with these three things. Notice that Ca is not there. So I know CaF2 is soluble. I need to do the same thing for aluminum chromate. I go back to table F. Chromate is right here. And chromate is going to be insoluble except when it's with calcium, magnesium, and ammonium, or something from group 1. What we need to do is look at aluminum. Aluminum is not in group 1, and it's not one of my exceptions. So that means it's going to be insoluble. It stays the same. So now I'm going to put this all together. I'm going to have my products that I'm going to write in. And then based on my solubility, I'm going to use AQ if it's soluble and solid if it's not. So CaF2 is soluble. That's why it gets AQ. Al2CrO4 is insoluble. That's why it gets the S for solid. And then what this tells me is one of these things are going to precipitate. And that is always going to be the solid one. Now, again, you may want to watch this slide several times to make sure you understand where things are coming from and how we get to different pieces. Let's take a look at the second example. In the second example, I'm starting off with Li2S and NH4F. Li is going to leave S and go to F. NH4 is going to go to the S. So I know what I need to look up on my periodic table and table E. So I'm going to have Li, F, NH4, and S. Now again, Li, F, and S are going to be on the periodic table. So Li is +1, F is -1, and S is -2. That's where these numbers come from. NH4 is going to be on table E. NH4 is right here. It has a +1 charge. So I have my starting pieces for my swap and drop. Now this one's going to be a lot easier because the numbers are not that complicated. So I have 1, 1. I swap and get LIF. On this side, I have a 2 coming across. So I need parentheses, and the 1 goes over. So my two products are going to be LIF and NH42S. Now I need to go to table F to find out if it's soluble or not. LIF, notice Li is the first thing. It's always soluble. So that one's an easy one. That's going to be soluble. NH4 and S, if I go to my table F, S is right here. It tells me that it's insoluble except with group 1 or NH4. Well, guess what? It has NH4, so it changes it to making it soluble. But also, this one actually shows up on this side as well. NH4 is always soluble. So here, I get 2 soluble items. So what does that mean? In my product side, when I write my answer, I get LIF, soluble, so it's AQ. NH42S, soluble, so it's AQ. And notice there is no solid here. So in this one, there's no precipitates. And that's a possibility. Again, you may want to watch this example a couple more times, pause along the way to make sure you understand what's taking place. Go back, try to do your examples one more time, and see how it goes. Enjoy, be safe, do some chemistry.